Hi, Eric Archer here from TI, and today we're going to work on learning about earthquakes, volcanoes, continental drift, plate boundaries, those kinds of things. So I'm sure you've all seen movies where there's a volcano or a major earthquake that's threatening humanity. Well, today we're actually going to learn how those things happen and why they happen. And so we need to understand what causes earthquakes and volcanoes to occur. Is there a pattern to these natural hazards? In this activity, we'll plot actual earthquake and volcano data on a map of the world. Using the data, we'll also discover the relationships between those events and the major tectonic plates that make up Earth's lithosphere. All right, so it's that top layer of the Earth that includes the crust and then the top part of the mantle. So the border between tectonic plates is called a plate boundary. So it's where those plates sort of slide together, and maybe think about the plates like my hands here. And so they move in different directions relative to one another. And for each different type of relative movement, there's a different type of plate boundary. And the plate boundaries can be described as convergent, where they're coming together, they're colliding into one another. Divergent, where they're moving apart, or transform, where they might be sliding past one another, sort of like this. Hopefully you can see my hands here. And so those three kinds of plate boundaries are what cause these geological activities to occur, so earthquakes and volcanoes. And so that's what we're going to explore today. If you want to follow along the video and maybe pause it and take notes, you're welcome to do so. If you'd rather do the activity yourself, you can do that by downloading the software that I'll be using today. It's the TI-Nspire CX Premium software. It can be found at www.education.ti.com. And this activity is called Ring of Fire, which we'll talk about here in a little bit, why they call it the Ring of Fire. It's one of the major plates. So that activity can be downloaded free off our website at www.scienceinspired.com. Okay, with that, let's get started. All right, so I have the file Ring of Fire opened in my TI-Nspire CX Premium software. You can use this file as well as any file from Science Inspired using this software, or you can open it up on a TI-Nspire CX or CX2 graphing calculator. Over on the side of this page, we've got a picture of an eruption from a volcano known as Kilauea, and it's in Hawaii. This was back in 1954. This volcano is still active today, off and on, but it's still a very active volcano. And if you ever get the chance to go to Hawaii, you may actually see a sort of a lava flow like you're seeing in the picture, which is really cool. All right, next page. Just a couple of questions to get some background information to you. Volcanoes and earthquakes can be found in the same locations. Well, we're learning a little bit about plate boundaries and how those interactions occur. We know that volcanoes and earthquakes typically occur at those plate boundaries, but not always. And in fact, sometimes volcanoes and earthquakes can be found at the same locations, but not always, and definitely not never. So you've probably heard of earthquakes happening where there are no volcanoes, and so that's another, one way to think about it. Sometimes, every now and then, California will get an earthquake where there's no volcano present. So that's the answer to that question. Sometimes. Page 3: the edge of a continent is the same thing as a plate boundary, and you'll see more of this a little bit later. And you may have already had some background information on this question, but the plate boundaries are typically below the ocean surface, below sea level, and although sometimes the edge of a plate boundary runs alongside the edge of a continent, the majority of the time that's not the case. That a continent may sit atop a plate boundary or a plate itself, but those plate boundaries and continent boundaries are not necessarily the same thing. All right, now we're moving to instructions on what to do on this simulation. And so what we're going to do, we're going to use latitude, which is sort of the horizontal lines, that imaginary lines you can think of that sort of help us find locations on the Earth. So the equator would be a line of latitude. And then longitude, which are the up and down lines, the vertical lines. So think about the prime meridian. We're going to use those coordinates that are on the student activity sheet, and I'll pull up a table from the student activity sheet. And then we're going to follow those coordinates. We're going to drop yellow points along a map to identify where recent earthquakes have occurred. And by the way, hundreds of earthquakes happen every single day, most of which you don't feel, but they're happening. So, and that happens because the Earth, being a dynamic system, it's constantly moving. These plate boundaries are constantly interacting. After we do this, we're going to answer some questions on page 7. Okay. All right, we're on page 5, and this is the simulation page. So we're going to select either the volcano or earthquake checkbox. We're going to start with earthquakes, and we're going to move our cursor to the desired latitude or longitude. So you may remember that latitude are the horizontal lines, that they're imaginary lines that go around the Earth and sort of give us the ability to locate places based on degrees, latitude, and longitude. So the latitude's the horizontal ones, the most famous being the equator. And then longitude, those are the vertical lines going up and down. The most famous one of these is probably the prime meridian. It runs through Greenwich, England. And so we'll use these coordinates to locate different places on the map. And we'll drop a pin at those locations, and then we'll clear the pins from the Documents tool menu when we're ready to move on to volcanoes. All right, so I'm going to dismiss this. So what you're looking at is the Pacific Ocean, pretty much all of it. And, so here's North America. This is where the majority of us live. South America, Australia is there. China's over here, Japan, and so on. There's Alaska up there. And so you'll notice as I move my cursor, the latitude and longitude change. So when we're thinking about latitude, remember I mentioned the equator. So if I get right about there, that's the equator. You see how it says 0 degrees? And then longitude, I don't have England at my access to England, but I do have the back side of that, which would be 180 degrees, which I'm having trouble. There it is. So this would be the sort of the other side of the prime meridian, if you will, 180 degrees. So so the longitude would be going this way, latitude's going that way. All right, you got it? So I'm going to pull up a table now. Hopefully you can see this on the video. And these are various locations around the Pacific Rim. They call this whole area the Pacific Rim. There's a lot of geologic activity that happens there. So I'm going to do the first couple of these so you can kind of see how it's done, but I'm not going to bore you by dropping all of these pins in real time on video. What I'll do is I'll drop the first couple, the first few, and then what we'll do from there is I'll kind of jump forward in the video with all of them dropped. That way you don't have to sit here and watch me drop, close to 20 different points. You'll get the idea. All right, so the first point is Vanuatu, I think is how you pronounce it, and it's at 19 degrees south, which means south of the equator. So you'll see how it changes. See how the latitude right here? Watch it. So when I move up, it's north. When I get past the equator, which is, right here, right there it was, 0 degrees. There, that's the equator. When I go south of the equator, it says changes from an N to an S, and so I need to get to 19 degrees latitude, and longitude is 169 degrees east. And that means it's on the east side of the prime meridian. There, right here. Nope, too far. Whoops, 169 is right there. 19, there we go. All right, 169 east longitude and 19 degrees south latitude. So I'm going to drop a point. lost my map. Next thing is south of the Fiji Islands, 24 degrees south, 179 degrees west. So we're going to go south 24. So we're on that line of latitude, going this way. And we need to find 179 degrees west. There it is. Need to go down just a tad. So right here. All right. Let's do one more, and I'm going to stop the video so again, so I don't bore you guys to death by dropping points here. But it is interesting, actually, seeing how these points, the pattern that takes place. Next one is Vostok, Russia. So some of you who are into the space program may recognize Vostok. That's one of their big rockets is named the Vostok. So 49 degrees north and 153 degrees east. Yep, right there. Okay. So I'm going to stop the video and I'll come back when I'm done. Okay, so you may have noticed the video kind of jumped forward and there's a bunch of yellow pins here now. That's because I stopped the video earlier and dropped all these pins just to save a little bit of time. But take a look at the screen and take a look at where these yellow pins ended up. Now remember, these are earthquake locations. These were these locations here in this table, and these are all the coordinates of where those earthquakes took place. So think about where or what kind of pattern do you see here. What kind of pattern is this? Now I will tell you I made one mistake. I dropped a pin here by mistake, so sort of ignore that pin. But otherwise, if you see these pins kind of running up the coast of Mexico and California, up into the northwestern coast of the United States into Canada, along Alaska here, you'll see this ridge, and then these yellow dots here along the coast of Japan, all the way down near Australia. You'll notice that it forms kind of a circular shape, and this is that Pacific plate. These are the boundaries of the Pacific plate, and so there's a lot of movement that's happening there, and as a result we're seeing obviously some geologic activity. Now you'll notice there's a earthquake that happened here right in the middle of this so-called ring of fire. It's not on a boundary plate. In fact, it's in the state of Hawaii. So it's just to show you that earthquakes can occur outside the boundary, the plate boundaries. So that's what's going on there. But yeah, and so by the way, that is Hawaii. They're in the middle of the Pacific Ocean, so that's kind of neat. It's pretty far away from everything. So anyway, moving on to, let's move on to the next page here and see what it. So describe the pattern of earthquakes on the map. I think you could see there pretty clearly that it makes a nice sort of ring. So a circular sort of shape, really follows the boundary lines of the Pacific Rim there, or Pacific Plate rather. Did the earthquakes occur on the edges of the continents? Well, the answer is not always, because that's, we saw one in Hawaii that wasn't on the edge of the continent. Answer certainly isn't never. We saw that in the map, there were some examples on the edges of the North American continent. There's certainly some earthquakes. So we could safely say that, yeah, sometimes earthquakes do occur on the edges of continents. All right, now it's telling us to go back to that simulation page, and we're going to change it to volcano. And using latitude and longitude coordinates on the student activity sheet, drop red points where volcanoes have erupted, then answer questions. Saying do not clear all your pins or you'll lose your earthquakes. So I don't want to have to drop all of those again. So I'm going to be very careful. I'm going to select volcanoes this time, and I need to pull up that table with all of the volcanoes. All right, so let's take a look at that table there. Here it is. The same thing I'll do on this one that I did on the earthquakes. I'll drop a couple of volcano pins and then I'll stop the video. It'll just jump forward for you and you'll see a bunch of red pins in addition to these yellow pins. So the first one's Mount Adams in Washington State, so I know that's kind of over here. I need to find 46 north on my latitude and 121 degrees west on my longitude. And so I need to go that way. All right, 46 north, 121 west. So I'm going to drop a volcano pin right there. Let's see, the Mariana Islands, 18 degrees north and 146 degrees east. So that's going to be over this way. 146 degrees east. I got to go that way. 18 north, 146 east. No, is that right? Yeah, 146 east. Okay, so drop a pin there. Okay, so in a second you'll see the video jump forward and you'll see a bunch of red pins. All right, like a typical cooking show, you'll notice that I'm done. so I pulled this one out of the oven, so to speak, and it's all ready to go. It's all done. So I got all the volcanoes dropped on the locations. There were a couple of locations off the grid, but for the most part, everything sort of was available. And you'll notice that there are some common places where earthquakes and volcanoes occur along these plate boundaries here. But then there are some exceptions, like the earthquakes, where there's volcano but not necessarily an earthquake. So that's pretty interesting. So anyway, so you'll see similar patterns here. That's why they call this the Ring of Fire. There's a lot of geologic activity, a lot of volcanoes around here that are active. And so I'm going to jump back down here to page 10. Did the volcanoes occur in the same locations as the earthquakes? And like the previous time we answered this question about the earthquakes happening at the boundaries of the continents, the answer is sometimes. So not all the time, but there was a lot of overlap, and you can see that. There are a lot of volcanoes happening along the same locations as the earthquakes, but then there are also a lot of volcanoes that were happening in locations where there was no earthquake recorded. Okay, and so let's see, where are we now? Page 11. Which of the following is true based on the data points you plotted? Select all that apply. Volcanoes always form on continent boundaries. Volcanoes can form in the ocean. Volcanoes cause earthquakes. Volcanoes and earthquakes occur in similar locations on the earth. Well, let's see. The problem with this answer is it says always, which we know that that's not the case. So this is not an option. If it would have said sometimes, then this would have been a good option. Volcanoes can form in the ocean, absolutely, and we could see that on the map. So that's going to definitely be one that we can choose. Volcanoes don't cause earthquakes, but volcanoes and earthquakes can occur in similar locations on Earth. So that one's definitely true. Okay, so volcanoes can form in the ocean, and volcanoes and earthquakes can occur in similar locations on Earth. All right, next page, page 12. Earth's crust, also known as the lithosphere, is broken into oceanic and continental plates, which float on the asthenosphere, which is the upper layer of the mantle. Okay, so the plates are always moving, and along the plate boundaries, mountain, building, earthquakes, and volcanoes can occur. So on the following page is a diagram of the Earth's crustal plates. Okay, so these are those the areas on the crust that tend to move, and so we've got the Ring of Fire, which we've done a good job of identifying the places where earthquakes and volcanoes occur. You can see on here there's a bunch of red dots that have been dropped. This is from the USGS, and so it's official. And this is on the Pacific Plate, and then you see Hawaii there, which we looked at on our map. And so all these little boundary areas, those are all different plates, oceanic and continental plates, interacting with one another. All right, compare the map you created on page 1.5 to the diagram on page 13. What crustal plate does your earthquake and volcano data identify? So if we go back up here, okay, and we look at our plates, so there's North America, here's Japan and China, Australia, South America, Mexico, and so we go back down to this map. North America, Japan, China, and so on. You'll notice that the plate that we were sort of plotting was the Pacific plate, which is this one. And it's, you know, the plate that's below the Pacific Ocean, so it kind of makes sense. Do the plate boundaries always fall on the continent edges? And so I think we've already answered this. The answer is no. Sometimes they do, but a lot of times they don't. And so you can see the Pacific plates going up the west coast of North America, but then it doesn't follow Alaska necessarily, and it's not following the Eurasian Asian continent here. So sometimes it does, sometimes it doesn't. All right, tectonic plates don't quite match the continents and the oceans on the Earth's surface. Is this true or false? I think we already showed that that was true. They don't quite match the continents and the oceans on the Earth's surface. So they come close, but it's not an exact match. Next question is, what other surface features occur near plate boundaries? Mountains, volcanoes, rift valleys, trenches? The answer here is mountains, volcanoes, rift valleys, and trenches. So it's all of them, all of the above. Plates move with respect to each other in three ways. They move together or collide, which are known as convergent boundaries. We talked about these. They move apart to form rift valleys, which are the divergent boundaries, so they're moving apart. Or they move past each other, which are transform boundaries, so they're kind of sliding past one another, but they don't necessarily form new lithosphere or destroy old lithosphere. That happens on the convergent and divergent boundaries. Transform boundaries don't do that. When a thin oceanic plate collides with a thick continental plate, the oceanic plate is forced under the continental plate. This is called subduction. So the oceanic plate tends to it'll slide below the continental plate. The continental plate will stay on top. And that process of one continental plate sliding below another continental plate is called subduction. But when two oceanic plates collide, one may be pushed under the other, causing magma from the mantle to rise, forming volcanoes nearby. And that's what's going on in a large part with the Pacific plate and the Ring of Fire. These deep oceanic plates are hitting one another. One's going underneath. It's basically sort of causing magma from the mantle to rise, and which forms these sort of underwater mountains, these volcanoes. Go back to your map on page 1.5. Think about the types of plate boundaries and what they can cause by their movements. Using the earthquake and volcano pattern, predict the kinds of boundaries in the Ring of Fire. All right, so sort of reinforce this exercise. Here are some questions. So what type of plate boundary is likely near Alaska? So let's go back to our map. Let's look up near Alaska, which is up here. And so we have some volcanic activity. There are some earthquakes that are happening. Typically, volcanoes are formed as a result of these sort of convergent forces that are happening. So we'll go ahead and go with convergent. All right. So transform boundaries typically can create earthquakes. All of these can actually create earthquakes, but the severity of the earthquakes depends on which plate boundary interactions that's happening. But convergent boundaries are the ones that are colliding against one another, and they're forming these sorts of violent interactions. And volcanoes typically happen when that happens. What type of plate boundary is near Japan? So let's go back up here, take a look. So here's Japan. We have some earthquakes, some pretty severe ones. There's also some volcanic activity. So I'm going to say, the Pacific plates hitting that Eurasian plate. I'm going to say this is most likely also a convergent boundary between those two plates, because we have the presence of volcanoes along the coast of Japan. And finally, what type of plate boundaries near California? So those of us that live in the States, we know that California is known for a lot of earthquakes. So here's Cali right here. There's a big fault there, the San Andreas Fault, which is basically when two land masses are, that faults form when the two land masses are sliding past one another. So in this case, we're going to go with, because here's California, up here's Washington and Oregon where they do have volcanoes. Down here we're getting into upper coast of Mexico, so really we're looking at an earthquake. So we're going to go with probably a transform boundary on the Californian coast. All right. So okay, so that, I think that's the end of this particular activity. I hope this made sense to you. I hope you understood the difference between the plate boundaries transform, convergent, and divergent. Also, hope you had some fun kind of seeing all of these places where earthquakes and volcanoes take place, and realizing that majority of those take place at the plate boundaries. Not always, as we saw with Hawaii, which also has an active volcano, by the way. But in most cases, that's where they're happening. Okay, so check out other lessons that I'm publishing on TI's YouTube channel. It's all one word, TI Calculators. You can search that on YouTube and find more of these. And don't forget, you can download the software and download any of these lessons and try them out yourself anytime you'd like at our website, which is posted on the screen. All right, thanks so much and have a great day.